Today we're going to talk about trigonometric identities, and this really kind of begins the wrap-up of trigonometry as we go through the school year. We will be getting close to the final here as we wind up the 9 weeks, and we want to have enough time to review and give you as much time as possible, time to review all the things that we did first semester for sure. So we're going to finish trigonometry in this unit, and then we just have 4 short lessons to finish the school year, and then we prepare for the final. So we're going to jump off with trigonometric identities, and these are not easy, I'm not going to lie. Now, everything on this note guide is review, all of it. Okay, so the first thing, we already know the reciprocal identities. Cosecant theta is 1 over sine theta, secant theta is 1 over cosine theta, and cotangent theta is 1 over tangent theta. The quotient identities, tangent theta is sine over cosine, and cotangent is cosine over sine. So all those things we already know. Now the Pythagorean identities we did go over earlier, I think last chapter, and we probably glossed over them just a little bit, but this is very important to know, especially the first one. Sine squared x plus cosine squared x equals 1, or we could say sine squared theta plus cosine squared theta. Get used to seeing theta from really most of here on out. And let me get that here. So that's going to be sine squared. So if you can just know that could be a theta on there. Well, let's look at this then. What does sine squared theta equal? Well, if you subtract cosine squared, you end up with 1 minus cosine squared theta. Well, what's cosine squared theta? Well, that's 1 minus sine squared theta. So all this stuff is usable, and there will be a red sheet handed out here today. And if you don't get it today, you need to get it as soon as possible, that has all of these identities on there for you. And you'll be able to use that on the final because they're also given on the final. So these 3 things are very widely used when it comes to proving identities and establishing identities. These 2 as well. But these are they come directly from sine squared plus cosine squared equals 1. And I showed these on a previous video lesson and in class. So I'm not going to go over that today. We've also talked about even and odd properties. For instance, remember that the sine of pi over 4, as an example, is radical 2 over 2, and the sine of negative pi over 4 is negative radical 2 over 2. Therefore, the sine of a negative angle equals the negative sine of the angle. So that's what we call odd. So sine and cosecant are odd, so is tangent. But if you remember, cosine is even, and I'll give you an example of that. Cosine of pi over 4 is positive radical 2 over 2. And the cosine of negative pi over 4 is also positive radical 2 over 2. Okay? So now we're going to use this stuff, and this is really what the focus is today. Simplifying expressions don't necessarily mean there's going to be a quote-unquote right answer. We're going to try to simplify these as far as they will go down, and same way with your homework today. So if we're going to look at these, let's first of all talk about it in terms of the identities. So if you think about it, what is tangent? Well, it's sine over cosine. So I'm going to change tangent to sine over cosine. Why? Because I have a cosine over here. And when I multiply using the distributive property, I multiply, you see something occurs. We have some cancellations. So we have 6 cosine theta minus 14 sine theta, because these cosines would cancel in the second part of the binomial. So that would be simplified. Can't do anything from there. We're going to do the same thing on b. Now that we kind of have an idea what we're looking for, we know that tangent is sine over cosine. We would distribute, that's 6 sine theta cosine theta, and yes, we will see that a bunch. We could have back-to-back sines and cosines and things like that, minus 8 sine theta. Notice that the cosines again would cancel, and that would be our simplification. Now, we get into a little more difficult realm when we look at these types of problems, okay? Secant squared theta minus 1. Well, this is a good time to look back at the secant squared theta, and I'm going to go back here. If you look at your sheet, that equals tangent squared theta plus 1. So what if I replace secant squared with tangent squared theta plus 1, and then look at it in terms of tangent? Well, looky here. That's 0. So I end up with tangent squared theta over tangent. Well, tangent is going to go into tangent squared one time, and we're going to be left with tangent. So that's an easy simplification. Now, if we didn't know this little identity, we could go through the process of changing this to sine and cosines and simplifying algebraically, which we're going to get into the guts of that here on this problem. Okay, so how do you add fractions? Well, I'm going to give you an example first because we're not very good at these. So let's add 3/4 and 7/9. Okay, what do we have to do in order to add fractions? Well, if you set a common denominator, you would be correct. Well, I believe that's going to have to be 36 then. So we multiply the numerator and denominator by 9 on the left side and 4 on the right side, and we get 27 plus 28 over 36. Well, we're going to do very similar things on sines and cosines problems here. So when we look at this, we have an addition problem. We have a problem we don't have a common denominator. So we would multiply this left side by sine over sine because it's missing sine. So we're going to multiply by, and I'm going to put this in parentheses for a reason because we have to distribute it if we're going to multiply it. Now the other side, we're going to multiply by 1 minus cosine because that's what we're missing in the denominator. Because the common denominator is going to be 1 minus cosine times sine, just like up here it was 9 times 4. It's the same concept. So now I can see that I can multiply my sine times sine and have, now here's a little trick. Don't multiply your denominator unless it looks like it would simplify. In this case, you'd just end up with sine minus sine cosine, which wouldn't help any. So we're just going to leave it like this. Then we want to FOIL. So I'm going to FOIL this. And I believe you end up with that all over sine theta, 1 minus cosine theta. Now, typically, guys, I skip that step and go right to writing it as one fraction. And I hope you're okay with that because from here on out I will. So I just write this as one fraction. So then we would have sine squared theta plus, well, let's see, 1 minus 2 cosine theta plus cosine squared theta. Now, if you paid attention to your Pythagorean identities, you should recall that sine squared plus cosine squared equals something. And then I got my denominator, of course. So sine squared plus cosine squared is, I know you're going to say it, it's 1, isn't it? So 1 plus 1 is 2, so you have 2 minus 2 cosine theta over sine theta times 1 minus cosine theta. Nice. Well, you think you're done? You're not. Because we could factor out a 2. And look what happens. we can factor out a 2, and that leaves us with those two binomials canceling, and we have 2 over sine. But remember, any 1 over sine is cosecant, so it's actually 2 cosecant theta. So all of this becomes 2 cosecant theta. Okay, pretty cool. All right, if you follow along in your notes, we also talk about identities. Now, two functions f and g are said to be identically equal if f of x equals g of x, for every value of x for which both functions are defined. If that's the case, we call those identities. If that is not the case, if they're not equal, then or if it's not an identity, we call them a conditional equation we have to solve, and we will be doing that later. Now, establishing the identity is going to require us use algebraic manipulation and the fact that we need to know our identities. So, for instance, we're going to identify or establish the identity sine theta cosecant theta minus cosine squared theta equals sine squared theta. So what we want to do is we want to focus on the most difficult part. And then we want to take that and make it look like this, sine squared theta. So I just wrote the first one down, and we're going to go from here. So I believe cosecant, guys, is 1 over sine. So we rewrite it. But then you would guess correctly, those cancel. So I'm left with 1 minus cosine squared theta. Now, if you go back and look at your notes, we wrote that down in our identities that 1 minus cosine squared theta equaled sine squared theta. And this is one you need to memorize. So that is sine squared theta. And that checks because that was our goal. Oftentimes I get asked the question, is this the right answer? Well, the right answer, guys, is this, the process of getting to the other side, okay? Again, establishing this identity, it looks like the left side is certainly more difficult than the right side. So what we need to do then is we need to change the left side to make it look like the right side. So I'm going to start with tangent, and I'm going to change that to sine over cosine times sine plus cosine. Now you ask, why did you do that? Well, usually it's easier to work with sines and cosines. Well, look at there then. Sine times sine is sine squared all over cosine. That didn't help much, did it? Or did it? Because I have a fraction now, and to add fractions, you got to get a common denominator, which in this case would be cosine. Okay, so I'm going to go over here now. That would leave us with sine squared theta plus cosine squared theta all over cosine theta, because you'd agree that the common denominator is cosine. Well, we know that that's 1, so 1 over cosine is equal to secant. And we proved that this side equals, the left side equals the right side. We established the identity. Okay. Now the right side on this one looks way more difficult than the left side, so we're going to start with the right side. And I'm going to change cosecant to 1 over sine squared theta. And I'm going to change tangent to sine squared over cosine squared and see if that leads us to anything. Well, those are going to cancel. So that's going to leave me with 1 over cosine squared theta minus 1. Well, let's see. We need a common denominator, which in this case would be cosine squared. And that would lead me to have 1 minus cosine squared theta all over cosine squared. Now you ask, what good does that do us? Well, remember, 1 minus cosine squared is sine squared. And sine squared over cosine squared is tangent squared. And that was our goal. So you always got to keep in mind the goal when we're trying to establish identities. Now the last one is a fraction over a fraction. Now that looks kind of difficult. So I'm going to take the side that has the secant, and then we're going to manipulate that, okay? So I'm going to have 1 plus, secant is 1 over cosine. And what I end up with is that. Now, we do, in essence, then have cosine. So that's a start, because remember, we got to get to this side. We got to get to cosine. Well, we have our cosine now. Now we got to algebraically manipulate it. Well, I think we'd have to multiply by cosine. You want to operate on these individually, the numerator and the denominator. So we're just going to look at this first. Well, that would give us cosine plus 1 over cosine. Okay? Then let's operate on this one. Again, it's cosine over cosine, which is cosine theta minus 1 over cosine. Well, that leads us then, we're really close. How do you divide fractions? Well, we divide fractions by multiplying by the reciprocal of the denominator. So we're going to multiply by the reciprocal, which is cosine over cosine theta minus 1. You guessed it, the cosines canceled. And we now have cosine theta plus 1 over cosine theta minus 1, which is what our goal was anyway. Okay? Now, I would invite you then to grab that handout, and let's look at some of these that are given with empty spots. So on the first one, we have cosine x plus sine x tangent x, and that equals secant x. Well, obviously, the left side is the most difficult side, and they give us this. Okay, so now we're going to go to step 2. Well, that seems to me then that would be sine squared over cosine, because sine times sine. And if you've learned anything so far, we know that we need a common denominator, so I have to multiply cosine by cosine over cosine, which gives me cosine squared x plus sine squared x all over cosine x. And we also know that that is 1 over cosine, because sine squared plus cosine squared is 1. Now I skipped a step here. Step 3 probably should be this written out. I think they want you to write that out so you get a common denominator. That step right here, which you go here and then you go here. So this really is 3, this is 4, and then we have 5 and 6, and then obviously 6 is secant, because 1 over cosine. Okay, so that's the first example, extended example. The second one is really ugly. It looks like, anyway. All over 1 plus tangent squared x, and that should equal cotangent squared x. So that's the goal. All right. Well, that's where we're going to jump off, and that's what they give us first. Sine squared x plus cosine squared x plus cotangent squared x all over 1 plus tangent squared x. But then, step 2, they say, okay, that's 1 plus cotangent squared x over 1 plus tangent squared x. And the reason is because this, remember, is 1. So now we need to peruse our notes, and we will see, if we go back to this, we will see that we had some cotangents, and yeah, right here. So tangent squared plus 1 equals secant squared. So this down here would equal secant squared x, and 1 plus cotangent squared right here equaled cosecant squared. So this is cosecant squared x. All right, now step 4. What is cosecant squared? Well, that's 1 over sine squared. What is secant squared? 1 over cosine squared. So step 5 actually would be the division of two fractions, which is the multiplication of the reciprocal. So that's how we would get to step 6, which is cosine squared over sine squared, and step 7 then, which would be cotangent squared. The last two examples I'm going to just hold off on. That really should be enough for today. That's a lot of video to watch. If you would please go and make sure you look at your assignment. And this will not be necessarily due on Tuesday, but I want it done enough to be able to ask questions.